In this video, we're going to take a look at exponential regression. Exponential regression, like all types of regression, allows us to figure out an equation that approximates a set of data. Now, different types of regression fit different types of data depending on the shape, and one way that we can figure out what's a good type of regression to use is to look at the general shape of the data if we put it on a scatter plot. So I'm going to start by showing a scatter plot for the data that we have here, and we probably want to use technology for this because the by hand work, just especially as your data set gets larger and larger, becomes a bit challenging. So make use of the technology you have available. Here's an example of the scatter plot for this particular data right here. Now, exponential functions, remember, have a shape that looks, hey, a lot like this one, where we have this going up or down. Okay, this would be an example of a decay because we're going down from left to right, and it kind of looks like the decay slows down here. So it looks like we might even have an asymptote right here at 0 perhaps. So the first step to plot it and take a look, yeah, it does look like it would be an example of an exponential. So then we can use some tools, and you could use a graphing calculator, or there are lots of different tools available online. I chose this one, and I'll tell you where to get it a little bit later in the video, and there'll be a link in the information about this video. But I make use of that to analyze and come up with the best fit, you could almost say, the exponential regression situation. So the exponential regression, it's going to give it to us in this form right here, y equals a times b to the x power. That's the form for an exponential function, and then it gives us the a and the b, and it also tells us the correlation coefficient right here, which, remember, correlation coefficients, this being 1 means it's a perfect fit. So all of my data fits exactly. The closer it is to 1, the better my data fits. Remember, the correlation coefficient would be from 0 to 1. And the closer to 1 again, the better it fits. So for this one, my function's going to be, if I write it out here, filling it in, and I'll write it as f of x because that's what we have for our data. F of x equals, a is 24, and then we've got times b, which in this case is 0.5, and then that's to the x power. Okay, so there's our function. Now, why would we want to do this? Well, it will allow us to make predictions for data that fits in between, or maybe we could go a little bit outside of our data, but our best predictions are going to be things that fit in between. And this isn't real world data, but when we're working with real world data, that's where the power of regression really comes to life, and we can see why we would do something like this. So there's one example. Let's take a look at another example of this regression stuff, and for this one, a set of data that looks just a little bit different. And the first step again is going to be to make use of the technology and to go ahead and plot that, and we'll see what it looks like. Okay, so in this case it looks like we have a growth situation. We're starting up here and up we go with that sort of curve, so it looks like an exponential. So then we can again make use of the technology to do some work for us here, and we see that the exponential regression equation for this fits in something like that. Now notice this one has a correlation coefficient of 0.9999994. Okay, so it's not perfect. So that means the things that we get out, if we were to estimate, say, okay, what's the value at 2.5? Well, it's not necessarily going to be exactly that, because the correlation coefficient, it doesn't fit our data perfectly. Okay, so let's pull out that equation. Again, it's f of x, like so, and then A, in this case, 3.99, and I'm going to round to the nearest, let's round to the nearest hundredth, so 3.99, and then the B, 2.33, and that's to the x power right there. Okay, so there's my regression equation. Again, this one isn't a perfect fit because it's not 1, and we can kind of see that in our graph here. So, exponential regression, just a quick overview in this video. We took a look at how we can use some technology tools. First of all, noticing the shape of the scatter plot, and if it has that shape that we know an exponential function has, then exponential regression would be a good fit to come up with an equation, and we could use that, especially useful for real-world data where we're trying to make some predictions or figure out some values that maybe fit between some data that we have. The source for the graphs and the regression equations for this was right here at this website. Dr. Philippe B. Laval from Kennesaw State University, and you can go to that website right there, and he's got a lot of great tools for regression, so I thank him for the wonderful tools, and I hope this video is helpful. Keep working hard on your math. You can do it.